Hey there, good afternoon. Thank you so much for joining us for today's webinar on AI Lakehouse, the next frontier in data management and AI. The story of AI Lakehouse went parallel to, of course, the data lakehouse, and the evolution of that has been fascinating. We first had the data lake, which was able to store humongous amounts of raw, unstructured, and structured data, but in native format only. From there, we went to a stage called the data warehouse, which was able to store highly structured data and processing it for analytics and reporting. It then went to the data lakehouse, which was able to combine the flexibility of data lakes with the structure and data management capabilities of data warehouses. And from that enhanced capabilities came the AI Lakehouse, which is designed for enhancing or structuring specifically for AI workloads. Now, ladies and gentlemen, in today's webinar, we are going to be looking at the key benefits of AI Lakehouse, and this includes what AI Lakehouse is and how it differentiates itself from the traditional data sources and data solutions that we are having today. We'll look at real-world use cases which showcase how AI Lakehouse can drive innovation across industries, and of course, a live demonstration of the AI Lakehouse platform. And to do that, let me welcome my co-presenters from Google. Let me start with Harshad Satam. He is head of ISVs at Google Cloud. Harshad, thank you so much for joining us. It's a pleasure hosting you.
Thanks, Shomik.
Hi there. Up next is Kunal Dixit, Data Analytics Sales Specialist for India at Google. Kunal, thanks for joining us. Welcome for this webinar.
Hi, Shomik. Hello, everyone.
Hey there. Up next, Priyanka Deswal, Customer Engineer, Data Analytics Specialist at Google Cloud. Priyanka, pleasure having you with us.
Hi, everyone. Thanks, Shomik.
All right. And up next, we have got Avinash Shravan. He is the Data Analytics Sales Specialist at Google Cloud. Avinash, hi there. Good afternoon.
Hi, everyone. Thank you, Shomik.
All right. So we've been hearing, a whole lot about data lakehouses. And of course, in its evolution, the AI Lakehouse. Could you tell us a little bit about the evolution and also how it kind of differentiates itself from the conventional methods of AI processing and also data storage that we have today? Over to you.
Yeah, sure. So from our perspective, when we look at lakehouses, they've evolved. And it offers several advantages over conventional data lakes and warehouses, primarily on the integration side, and it brings the strength of both architectures while addressing the limitations, right? Both from the data warehouse and data lake. We can look at some examples like in modern AI Lakehouse, we see a single repository with unified data management. Basically, we're talking about a unified platform for all data types, structured, semi-structured, and unstructured. So basically eliminating the needs for separate data silos. And this integration basically helps and facilitates seamless analytics across diverse data sources without duplication of moment of data.
Okay.
The other big difference we see is that we are seeing more and more options of storing data, right, in open format. It gives at least not parallels to Google customers, flexibility of storing data in open formats like some famous formats which we see these days like Apache, Iceberg, those kind of options, and which basically brings the economies of scale when we're looking at data lakehouse storing a lot of data. When we also look at unstructured data, which is coming into play here, right? Then from the other standpoint other point of view, we look at schema side, right? So traditional data lakes uses a schema on read approach,
Right.
basically used for picking up use cases of machine learning, building models, and looking at your unstructured data, picking it up, defining schema, then doing some analysis on top of it. While Lakehouse is enforcing schema on write model, which ensures data integrity and consistency. So this is kind of bringing more structured approach and simplifying the data integration and performance. One big advantage we're seeing, again, and there are many, but I'm just putting a few here, that on the real-time processing, a lot of our IC partners are in the web commerce side, where they do a lot of real-time processing.
Right.
Where lake houses today support real-time analytics through distributed process engines, right? So we have options of uh, Flink, Kafka, those kind of things, Spark, right? So these are basically enables organizations to drive insights from streaming data sources more effectively than the conventional data lakes, which mainly designed to do batch processing. So these are few examples, and we can look at maybe more in terms of data governance, etc., which AI lakehouses are bringing. On the top of it, uh, it is basically democratizing the data with the power of AI. So you have today natural language queries which are used to getting insights from data for, let's say, business executives, and also giving on the non-business side, we're looking at giving a single user interface where uh, a workflow can be converted directly to a point and click visualization, and let's say in our case it'll be Looker, or you can establish or create a notebook and do machine learning analysis, etc. So that's something it's something also which is a good differentiator we have.
Fantastic. I think that's really good to know, and I'm sure our audience is really excited to see this and also hear about what Google Cloud brings to the table. Folks, it's now time for a quick demo, and we would want to know exactly how AI lakehouses can actually be brought into the picture. So we are going to be using natural language and using a query, how a query can be done with that. Also customer segmentation, personalization, and the favorite part, what audiences really love, is how do you actually make sense out of unstructured data. And for that, let me pass it on to our Google specialists here, Kunal and Priyanka. Take it away.
Hey, thanks, Shavik. Thanks for setting the context. So, good afternoon, everyone. It's been a lovely weather out here in Mumbai for the last few days. Hope it's the same everywhere else. So, today I'm excited to talk about Google AI Lakehouse. It's a revolutionary approach to data management. I mean, so Avinash briefly spoke about what are the powers of eliminating silos, bringing in the power of integrations and having a unified approach to everything. Now, rewinding back a few years earlier, okay, everyone has been aware of the challenges for a traditional data warehouse. Go back to about 10, 15 years ago, it was simply a SQL Server warehouse on which everything was being constructed. Data had to be cleansed, massaged, and then put into a small subset of an area where OLAP cubes had to be created for limited reporting to be done. Okay, so if I have to look at some key bullet points, extremely limited insights, higher cost of management leading to multiple systems, duplication of data, infrastructure, and slower speed of innovations. Now, when you say about slower speed of innovations, business is rocking up to ITs and saying, "Hey, I need this ad hoc reporting by next day, tomorrow." So everything was limited. Fast forward to say 2023, 2024, the advent of Gen AI changed the way everything materialized in the world today. If you look at the paradigm shift that has happened from SQL Server warehouse, people either lean towards either having a formal structured data warehouse, okay, when your KPIs were known, your reporting structures were defined, and your queries were well managed, to something on the advent of say a lake house. Now the lake house, the efficiency of a lake house came into allowed you to bring in a lot of unstructured reports which were open source in nature, reports which were flat files, allowing you to start modeling your AI use cases basis on that. Fast forward to say 2024, when Gen AI became the talk of the town. People wanted to do everything, but they wanted to do everything in real time. Quite possible even with today's lakehouse, but the limiting factor is the humongous task of engineering efforts in needed in order to ensure that there is seamlessness across the way the architecture is in place. Uh, this is where Google came out with the AI lakehouse concept in at an extremely high level, and we'll cover this in our demo. It allows you to keep your unstructured, structured, batch, streaming, all your data in one place. Scalable and cost effective. Why would we say that? It allows you to store data, as Avinash pointed, in open source formats. I mean, as ISVs, you are aware that people tend to prefer or have affinity towards a certain kind of an environment. It could be Apache Iceberg, it could be a SQL Server warehouse, it could be anything. Our AI Lakehouse allows you the flexibility to keep Iceberg open, structured, all kinds of formats, and it allows you to run a host of computing needs. It could be BigQuery, it could be open source technologies. And there are a lot of out of the box capabilities around AI powered insights. It has got built-in machine learning models. Priyanka will shortly show you what I'm talking about using the BQ canvas approach. So I mean, I don't want to take away any spotlight away from Priyanka, please cover that when we can. And the key, finally, to wrap it up, the biggest benefits that we have is it allows you to reduce your cost with open source formats for storage and multiple compute options. It gives you the faster time to insights. It allows you for agile data exploration, analysis across all sides of data. It allows you to have improved decision making. Think of a contact center agent talking to you, okay, and him having recommended insights rather than the customer getting qualified and qualified and qualified before a solution is being provided. You have something powered by AI that is telling what are the top three concerns for the customer, what was the solution provided last time, and how can we improve that better. And it allows you to have increased innovation, unlock new possibilities with advanced analytics and machine learning. Uh, just to give you a high level real world applications, if you're talking to a retail customer, you can personalize your entire customer experience journeys. I mean, we have been speaking about cart analytics for so many years and talking about optimizing supply chains. How about within 2 or 3 clicks, okay, we are making sure that the customer checks out with recommendations that are fine tuned to him rather than the next best product strategy. We go to a financial services organization. How can we optimally detect fraud? How can we better manage risk, and how can we give personalized finance advice uh, on the customer's behavior rather than the bank's underwriting? Take healthcare for example. How can we better discover drugs? How can we better forecast what would be the patient outcomes and put in as much amount of dollars to those kind of research? Finally, if I have to conclude in about a few seconds, AI Lakehouse from Google is just more than a technology. It's a paradigm shift. It's about empowering organizations to truly become data driven, to unlock the full potential of your data and drive innovations like never before. Priyanka, over to you.
Thanks, Kunal. Good afternoon, everyone. Let me just start by sharing my screen. Okay. So you heard my colleagues talk about a lot of benefits, why an AI lakehouse is needed, how the evolution of data warehouses have happened to data lake to lake house, and now we're talking about AI lakehouse. So taking over from there, one of the point that you heard my colleagues mentioned is that it should be able to support different kind of personas that you have in an organization. Your data should not be scattered, and neither should be your experience. So I want to start by showing you a couple of options here. So I've logged in into the Google Cloud Console, and I'm into the BigQuery service now, which is our flagship product, which provides you the AI Lakehouse. And in an organization, you will have different personas, right? You have data scientists, you have data engineers, you have data analysts, and all of them basically have experience or have an expectation in terms of different tools that they use, right? So there will be developers, there will be analysts who are comfortable with SQL query. There are people who want to write Python notebook. So what we have provided here is at any point in time a single place where the user can either write in his SQL query, and this is what you see right now is BigQuery Studio. You can basically write a Python notebook, which basically spins up a Colab notebook, and you can start working on it. And it has got a lot of benefits in terms of providing you capability of you get a lot of memory out of memory exceptions sometimes when you explore large data. So this Python notebook that you spin up using BigQuery can actually provide you a lot of scalability in terms of memory that you get when you are working on the Python notebook here. And then, there is an option of also working on Spark. You don't need to spin up any Spark clusters. You can directly write your Spark jobs and submit your Spark jobs directly in the BigQuery console. So we have addressed the users who write SQL queries. We have addressed the users who want to work on Python notebooks. We have addressed the users who want to work on Spark procedures without spinning up any clusters. And then finally, we have a new language which is coming up these days. And that language is the natural language. So that exactly is what Data Canvas is for. So what you can do is at any point in time, you can do your queries in a natural language, and you can use BigQuery Data Canvas to create all those things for you. So what we will do is, we will just try to give you a scenario for retail data. So I have two tables here. Let me just and then, by the way, you can even search for your tables in a natural language form. Okay, so we will just pick up two data tables that we have, and let me start with the first one, which is customer data. I'm looking for a table which is customer data, and you could actually sometimes even put some things in natural language to find out certain data in your data sets. So let's look at it. It's searching for it, and exactly, yes, this is the table that I'm looking for, and I just add it to the canvas. And then I would like to basically join this customer data. I can just query the data as it is, or I can just join this data. So let's say here, I can again search on it, but I know the transaction table is the one that I'm looking for because it was last recently used. So it's brought it here. Otherwise, the similar way you search the customer data, you can actually search for the tables as well. You hit on OK, it basically joins these two tables for you. Now what we are going to do is we are going to write in a natural language some of the questions that we are looking for. Okay, so let me just write a question here, and I'll just copy the question so that, okay, all right. Let me just increase the screen so that you can see it better.
Sure.
All right. Okay, so I have joined these two tables, and what I will do is I'll just switch on to a notebook which I already created in the interest of time. So what I have done here is, as you see, that I wrote a question in a natural language. Okay, the question was, what was the total sales across different product lines across different cities? And I hit, okay, I want the data canvas to create this query for me. So if I hit on it, I'm expecting it to come back and give me an SQL query. So see here, you were asking question in natural language, and it wrote the entire SQL for you, also made the join between the two tables. And you can just hit on run, and you can just get your results. So once your results are there, you can further query. You can actually write a lot of further queries on the top of it. You can join this data with some more tables. If you want to just download this data, you can download it. You can open it with Google Sheets. You can even explore this data and open this into a new Python notebook, into a new canvas, or into Looker Studio. But let's say, no, that's not what I want. I got the results that I was looking for. My next step is basically to visualize it. Okay, so what I've typed here is, help me best visualize this particular data. If I hit on this, what it basically shows me, it shows me the graph. It automatically generated this bar graph for me, where it shows me the product lines, what are the total sales across different cities. And if I hit on summary, so what it does is it basically uses generative AI to also explain what is there in my data. So it says that, for example, IT is a top performing product line, leading sales in most cities. HWs at Rapids demonstrate strong performance across all product lines. So it's also explaining what it saw in the data. What we can do now is we can just export this as a Python notebook. And I can just give it a name. If it's September. So what I have done is I have just saved this particular notebook. Now what I can do is it generates a Python notebook out of it. If we just hit on open, now I have a Python notebook available. I can give it to some of the developers who are more comfortable working on Python, and they can just go and edit, play this notebook as it is, which we have generated from data canvas, or they can just edit and they can use this particular notebook. So we use the natural language to basically also generate SQL queries, and at the same time, we also generated Python notebook out of data canvas. So this is how, for different personas, we are trying to amplify, we're trying to make life easy for the developers. Now, the second demo that I want to switch on to is basically around machine learning. Okay, so here I have taken a data set for a customer master, where I have details about the customer. I have his age, job, marital status, education, whether he has defaulted on the loan, and a couple of other information related to how I have targeted this particular customer. What was the duration, when I last spoke to the particular customer, what are the number of days that have passed by that time the client was last contacted, and so forth. So of all this data, which I have stored in a customer master, now what we can do is we can build a segmentation model. So earlier we used to create very few segments because it was even difficult to explain or understand those segments, right? So as you can see here from this data, instead of just creating 5 or 6 segments, I have created 20 segments. Using just a simple SQL statement, your data is basically there in your Lakehouse. You don't have to bring this data into any other platform. You can just create the model there and then where the data is. So that you don't even have a problem of data governance where your data is actually getting spilled into multiple places because you're trying to do some kind of AI projects. So here the data is there in the customer master. I'm just creating one more object, which is banking.customer segment cluster underscore 20, and I'm fetching the data from the same table which I just showed you. Okay, so I'm fetching this particular data and I'm saying I want to create 20 segments out of these. So let's run this, and let's then look at what. Obviously, it's going to take a time, so I just ran it pre-hand for you. So I'm just going to now run this particular cluster and show you how the clusters look like. So let's run this. So if I run this, you can see the different clusters that it has created, the 20 clusters it has created. What were the different parameters, related to age, last contact duration. So looks like these are the parameters, at least for the data that I have, that have highly impacted the segments which have been created by the machine learning model. So all the models are there inside your AI Lakehouse. You just have to say, okay, where my data is, and run certain models. Right now I'm running a k-means modeling. Maybe you are looking for building some kind of a churn prediction model. You want to build certain kind of anomaly detection model. All those things, you just need to change the name of the model and you're all set to build your models. Now, what more can we do on the top of this model? So I think one of my colleagues spoke about the generative AI capabilities, right? This is all we are talking about AI. How can I do some kind of personalization? So what I've done is I'm calling the Gemini Flash model on this particular cluster. And if you look at my prompt, I'm able to call my generative AI prompt directly from my SQL query. I don't have to again set up a new environment or a new program to call this. So the prompt that I have written is that pretend you're a creative strategist, and given the following clusters, which have been, by the way, generated by the machine learning model just in the step before, label the clusters and explain step by step what would be the next marketing step for this particular cluster. And I'm passing the fields, the rest of the fields of that particular customer segments to this prompt. Okay, so let's run this. So as you can see here, this is just a SQL query, and using the SQL query, we are able to generate personalization for these particular segments. Okay, so let's look at this. So as you can see here, for all of my clusters, it basically brought in results in terms of the complete explanation that we have asked for. Okay, so if you look at the complete cluster analysis, it provides that, yeah, these are basically the points. What is the age? What is the last contact duration for that particular user? And then it also brings in certain kind of attributes for you so that you can understand this persona better. The next one I wanted to show on the same data is I'm trying to generate some kind of a customized message. Okay, so I'm just hypothetically putting the name of a bank. You could have just used any bank. I'm just putting a name of a bank, that pretend you're a creative strategist for an ICICI bank. And we know that obviously generative AI is trained on a lot of data sets, so it understands what are the offerings that ICICI bank has. If it was some other bank, and if you would like to fine tune the model, the generative AI model on your offering, that is also possible. But as of now, it's just the generic model that I have taken. And so what I'm saying is analyze the clusters and tell me which is the offering which this user is more likely to accept based on his particular persona. So again, this is the select statement SQL query, and I'm writing a generative AI prompt to run this particular query. Okay, so I am just running it. I'm parsing this information. So let me just run this. Okay, so it's executing our query. And as you see, for the cluster one, it feels that the first offering ICICI Bank's everyday banking package. Why? Because this particular persona is a busy bee. This cluster represents individuals who are constantly on the go, juggling multiple responsibilities and needing a banking solution that keeps up. They value convenience and efficiency and are likely to be tech savvy. Okay, and then this is a small witty subject email subject line: stop juggling, start banking smart. So this way you can actually use the generative AI capabilities to create a lot of personalization based on what you know about the customer or based on what you know about the segment. Right now we have done personalization per segment. You could actually just do it like, whatever information you know about the customer, you can actually use generative AI to create these kind of personalization effects. So this is basically on the cluster side, on the machine learning capabilities that you can do with it. Now coming over to the unstructured data, what is that we can do here? Okay, so what I have done is I have basically got some KYC documents, like, actually just two KYC documents, which is basically the PAN card. And I would like to basically extract the structured information from this, and I would like to run an SQL query on the top of this particular data. So that's what I'm trying to do. So what I do is I just create a parser in Document AI, Google Cloud Document AI, and I'm using this pre-trained foundation model, and I will call this foundation model on the top of that data using an SQL query. Okay, so let's come back to the script here. So what I have done is, as you can see here, I created a model for the Docker AI parser that I already have, and I'm building a remote connection with that particular model. Okay, and just to highlight here that obviously BigQuery has got a lot of inbuilt machine learning models, but you can always also import your own models, which you have trained. So right now, if you look at it, I'm basically referring to a remote model, which is a Doc AI model, which I had built, which I had cataloged in the Document AI, the screen that I just showed you a while back. So what I have done here is I've created an external table called bank stats on the top of that. And I have my documents stored there. And using just a select query, what I'm able to do is I'm able to call that particular model, I'm able to parse that particular data, and I'm able to fetch the structured data out of it. Okay, so let's look at this. So as you can see here, when I ran the Doc AI parser, it extracted the information and it gave me a JSON object for whatever it found, on my particular document. Okay, so let's do one more script. Okay. So what I have done in the next step is I have also parsed that JSON for you so that I can show you. You ran the query, you got the JSON object, out of the Document AI, but obviously you would like to see that in a complete structured form. So there are three fields that I'm extracting for those PAN card, and I would like to basically see it in a structured format. So as you can see here, once I ran my query, I basically used the inbuilt capabilities and functions of BigQuery, and I was able to parse that document. And now I basically have for those two PAN cards the name, PAN number, and date of birth, in a proper format. Okay, so this is basically showing you how even your unstructured data, you can just query from one single place. You can just catalog it in one single place. You don't have to split it across multiple sources. Then coming over to the functionality, which we were talking about, the Lakehouse, right? The open data formats. So, my colleague earlier spoke about, we support a lot of open data formats. Customers want to store data in their, in the open source formats, Parquet, Iceberg, and they would still, want, some kind of functionality. For example, our customers were talking about that we have to do a lot of file management of these open structures. We have to do security management of these files, which are there in the open source formats. So that's what exactly we have worked on. And what you see here is basically a big lake managed table. And this is one of the feature which is there in preview, and it provides you a lot of features in terms of schema evolution. You can add, drop, and rename the columns. The example that you see on the screen is basically an open data format, Parquet, where the metadata is an iceberg, and the Big Lake managed tables automatically does the storage optimization. It does adaptive file sizing based on the table size. It does automatic reclustering, automatic file compaction, automatic garbage collection. So you don't really have to get into understanding, okay, how, if I'm streaming the data like this, should I do schema on read, should I do write on read? So you don't have to worry about copy on write, merge on read, how will I do file compaction, do I have to run any particular kind of utility? BigQuery will manage all the file management for you in this PLMT. So let's look at what exactly is happening in this particular table. So created a small table called nation, which has got a couple of fields: nation key, name, region key, and comment. And I'm creating it in the form of a Big Lake managed table format. Okay. And as you can see here, the file format is Parquet and the table format is iceberg. And I'm basically referring to this file that this actually has a data into an external storage, which is a GCS bucket. So the point to note here is that the data is not getting stored into BigQuery. It's actually getting stored into a cloud storage, into a open format, which is Parquet, which means it is accessible to you at any point in time from your other tools also, because it is an open format. You can directly use it in that particular format. And if you look at it, I can just insert a couple of records into this particular table. I think I already inserted these 2 records, but I'll just insert a couple of times more since there is, okay. So I inserted it. If I select this particular data, you will see 3 records. And I want to show you where exactly these records are getting stored, okay. So let's query this data first. And you can see, I inserted this data into a Big Lake managed tables. I got the record 3rd time as well. 2 times I inserted earlier. So now if I come back to my GCS bucket, the path which I have mapped for the BLMT object, you see one more file which just got created at 3:32. Okay. So what it's basically doing is whatever records I'm inserting, whatever data I'm loading into that table, it's actually storing it into a Parquet format in BigQuery. Okay, so that's the strength of BigQuery, that it's able to give you the richness in terms of functionality, of what the BigQuery query engine provides. At the same time, your data is getting stored into a open source format. In this particular example, for example, it's Parquet format, and you can just have the best of both the worlds. Yeah, so this is what all that I had to cover. With this, let me hand it over back. Thank you.
All right. Thank you so much. I mean, that was a fascinating presentation. All right. We saw plenty of use cases out there. And at this point in time, I would want to open Harshad. Now, Harshad, we've seen, what Priyanka has just shown us and Kunal as well, an entire SQL query being created out with natural language input. We saw the possibility of tapping into unstructured data. Now, as the man heading ISVs for Google Cloud, could you explain what it means for businesses? What are the possible implications? What kind of impact is this going to create?
Hey, thanks, Shami, for the
make a SQL query or do analysis using both, how do we join this data sets, which Priyanka already showed, right? How easy it is. So we're seeing that it's basically eliminating the data silos. This kind of integration in AI Lakehouse is also eliminating the duplication data movement, right? The other aspect which we see is that what we've seen earlier that typically data lake were used for batch kind of workloads or data warehousing, etc. Right? But now we're looking at real-time processing, like we saw right now, right? We are looking at from our perspective, we're giving that multiple options as Harshad talks about, right? Whether it is for storage option, we are looking at supporting Iceberg. We have Apache Hudi. We also support Delta formats, right? So it's a whole lot of options which customers get today. The aspect on the engine side, we've also seen that from the single interface today, without even looking or going into a different console, from the interface tooling perspective, we have SQL users or data science users that are using Python or some other users, right? You want to use some other engines for their workloads, they can simultaneously work on the same platform without being bothered about how to do provisioning of those infrastructure which are required to do those use cases or workloads which they have in their environment. Basically, this enables organizations to deliver insights from streaming data sources more effectively, right? Because it's we looked at the other question coming in where we talked about speed, right? So when we looked at traditional data warehouses where conventional data lakes and data warehouses would often struggle with timely data processing, that something is getting eliminated with the options customer get today. BigQuery also has something called, which we recently introduced as real-time querying, right? So we are looking at helping our partners and customers to have, as and when data flow in, right? You can run queries right there. It's not micro batch, which we typically do for streaming use cases, but we are looking at writing, transforming that data, and probably giving it to downstream application in real time. And this is being very prominently used these days and looked at very seriously when we look at fraud analytics and some of the marketing use cases where social media responses are created automatically using Gen AI. So the timeliness of response, the accuracy of response has increased. While we're doing all this, one of the major concerns, I think Priyanka touched on that, is how do we do data governance, right? Like we have like different sets of data, all this is happening. So the AI Lakehouse today incorporates built-in governance features, basically ensuring your data quality, consistency, and reliability across the data sources you have, whether it's unstructured, structured, or semi-structured data, right? And it basically helps organizations to meet their compliance measures and data lifecycle part of it. So I think that's how would I sum other than the AI capabilities which are sitting on top of it to help you give natural language interface, which substantially changing the way data platforms are being used today and will be used in the future.
Got it. Got it. Thank you so much for that, Avinash. Now we did, hear a lot about what it can do with data, and also how you can, achieve more agility with that. And my next question is going to be on the business implications. We're going to be talking money now, and Harshad, I would want you to chip in with your inputs as well, because you've partnered with a lot of ISVs, and this next question is a top priority for a lot of the people that you work with. So to start with, I mean, if you could tell us, slashing TCO and achieving cost optimization at this point are top priorities for the IT leaders. When you talk about AI lakehouses, how do they align with this particular objective?
Yeah, I think that's a question that we typically get once we've done with understanding the use cases, right? Because for a lot of customers, the fact that it has to increase TCO sort of sometimes deprioritizes such projects, right?
Right.
And the good thing is that we understand the customer need, right? At the same time, we don't want them from stop innovating with us on the platform. We have actually got a very, uh, uh, what do you say, specific program that we are running. Let me just share my slide around that. Just give me a moment. So we have actually launched a data analytics migration program. This is available for new as well as existing customers. And this program is a combination. It in a way de-risks the customers not only from a technology point of view, but also from a cost point of view. Uh, you have to look at a migration, you have to look at refactoring for data workloads. Then we are sort of providing that those kind of monetary benefits as well, right? So we look at not increasing the TCO for our customers. If anyone needs more details on this program, feel free to reach out to anyone on this call. You can reach out to Kunal, Avinash, myself, and we'll be happy to see that this program sort of helps you on your journey.
Sure. Thanks for that, Harshad. I think that's the ultimate intent. And folks watching this, feel free to reach out to the ET team as well. We'd be happy to connect you if you're looking for any kind of solution that could fit your organizations. All right. Now, coming to the next question, could you explain, can AI lakehouses do a better job when it comes to real-time decision-making capabilities? And if that is yes, if you could explain why.
Yeah, sure, Sonik. So we're looking at while we covered, Harshad covered about the program we have, we also get majority of time this question that how this is better, right? Can do a better job, and some of that we've already seen in terms of ease of use, etc., in terms of flexibility, in terms of options, in terms of single unified interface when Priyanka demonstrated. Some of the key things which I think for real-time decision-making capabilities required is that once you have the data at a unified data storage, and I'm talking about all the data which organizations have, whether it's structured, unstructured, or they all coexist right here in this architecture. This means that for any real-time data pipelines which you have to create for analysis, we don't need that complex ETL running from different sources, right? Which used to traditionally happen when the data were in silos. The second is that, like I explained in the previous, while answering the previous question, that this is like when we're talking about efficiency gains here, we are looking at some of the use cases which I talked about. With given the options we have, we can do it more effectively in terms of fraud detection, customer engagement, which Priyank also talked about. The other thing which is very crucial when we look at real-time decision making is advanced AI and machine learning, right? So today, lakehouses can integrate machine learning models directly with data, and this is actually allowing organizations to have to run predictive analysis in real time. For instance, a business can use real-time data to adjust marketing strategies and optimizing supply chain instantly, right? Looking at demand, looking at customer sentiments, etc. We already talked about how the AI Lakehouse is structured to help process streaming data, right? Like I initially touched upon Apache Kafka, Apache Flink, and both of these Google today has as a managed service. So we're looking at a lot of streaming processes frameworks which are open source today. We are keeping in mind that we want to give customers a choice of technology they want to use and still help them achieve higher TCO, better performance. Right? So we have this services built as managed services on open platform, which can enable continuous data ingestion, processing, and allowing timely insights. I think other than this, the collaborative environment which we talked about, which Priyank also showed, is fostering a culture of data-driven decision making across organizations. This is basically helping our partners and customers innovate faster using the data platform, right? So that's how I think it's helping in real-time decision making capabilities.
All right. Great points there, Vinash, and thank you for that. Now, we see a lot of companies right now taking their baby steps into AI, but there is an industry report, quite an alarming one, in fact. According to a recent Gartner report, 85% of AI projects fail. So, maintaining high data quality and reliability and consistency, they're essential for the success of AI ML models. So, if you could explain, how is Google's data cloud for ISPs approaching this challenge? How are you ensuring your partners or ISPs are able to get AI right the first time?
Thank you, Shamik. I think we've touched a very crucial point, and we, in all our effort and our thoughts we have at Google, we want to help succeed customers, right? So, and our partners. We're looking at data quality, reliability, and consistency are crucial for building accurate and trustworthy AI ML models, and Google Data Cloud tackles these challenges in a multiple ways. Uh, we have we looked at that, once is that unified approach which Priyank already talked about. But other than that, on the data integration side, we have tools like Dataplex, which helps break down the data silos, connect various data sources which are in different storage system. It could be cloud storage, it could be one of our databases like Alloy DB, Spanner, or BigQuery, without requiring data movement. So we are able to create a data catalog and establish a relationship with that data for governance, for policy creation, and also to ensure that your AI ML models have complete and consistent view of the data across the uh, data landscape organizations have. We also have another thing which is important is data quality management, right? So when we talk about data quality, Dataplex as a service helps automated data quality checks. So it can scan your data, infer metadata, apply predefined or custom rules to identify data quality issues. This basically helps in proactively, detecting and addressing inconsistencies, errors, and some missing values. Which when we look at how we're preparing data for AI and machine learning use cases. One important thing also here is data profiling. Right? Data profiling capabilities, which Dataplex gives, helps you understand the characteristics of your data. We identify potential biases, which is very important, right? If data is biased, the machine learning models will also be biased. So, looking at this consideration, we ensure that it meets the requirements which is required to build a robust AI ML models. The other thing which we have is about monitoring and alerting. We typically look at notification of data quality issues of paramount when we look at AI ML workloads, right? This basically allows our customers to corrective actions are taken for issues those are affecting the which can potentially impact the AI ML models. So these are a few things which I think we look at. The fundamentally our approach has been that we don't look at having basically the approach here is that bringing AI ML models to your data instead of moving data outside. So we've always been looked at that how we bring models even in the Vertex AI and Gen AI. Google stepped into that era, Gen AI era. We looked at that how we facilitate models being brought to data instead of data moving outside for machine learning use cases. And if you look at today, BigQuery itself as a product has a vector database that can instantly help customers, those who are running BigQuery, to to use that for their generative AI use cases. So this has been thought well in terms of how to architect it so that it is minimum movement of data. We give a lot of importance to quality governance and so that the integration of data platform is and the quality of data and reliability, consistency are taken care of. I hope I was able to answer that.
I think I also wanted to answer the second part of your question around how does this benefit ISV? Okay.
Please.
So I think Avinash covered most of the points, but just to summarize, providing this comprehensive set of tools and services around integration, transformation, quality management, which Avinash spoke in detail, what it allows is it allows you for improved model accuracy. Plus for an ISV, one of the key aspects is the faster time to market. You'd want to be one step ahead of your peers in the industry, and possibly two steps faster to what the customers demands are. So having that faster time speed, having a better model accuracy, Google does a fantastic job around that. And this reduces your overall development cost. And
Right.
by combining all these three aspects on a trident, you essentially are winning your end customers trust. Okay, so for an ISV, during a POC or a demo back, made the entire foundation made on Google Cloud, you keep winning your customers trust, and that allows you to win much more newer projects from that end customer. So I thought that why does it benefit the ISV, or something possibly I wanted to cover up as well.
Thanks, Kunal, for chipping in. And yes, ISV is one of our core areas of focus because the ISV space in India looks very promising. There's a recent report that says the SaaS startups market in India will see a 25x growth in the next 9 to 10 years. So, I mean, if I'm looking at it from an ISV's point of view, what does AI Lakehouse bring in terms of driving faster innovation and, very importantly, optimizing AI workflows?
Yeah, so yeah, very valid question. From the IC perspective, most of our engagements are in the rapid prototyping and development, right? Because product is the interface which ISV is known for, right? So it's an experience which ISVs create today with Google, and the unified architecture which we talked about today in AI Lakehouse allows our ISV partners to quickly prototype and develop new features by accessing diverse data types without the need for or a complex integration, like we've been discussing, right? So this basically accelerates the development cycle. The other aspect is that we are consolidating all the data storage with all the options and with compressions which AI Lakehouses provide today. Besides eliminating silos, it gives tremendous amount of cost savings, which is important when we're looking at developing this new prototypes or expanding markets, right? The cost is one of the major concerns. So speed and cost and effectiveness for the development of the prototype is what what we consider here. Then the other aspect which most of the ISV partners we worked with are looked at that how we seamlessly integration with other tools, right? Because the ecosystem is vast. When an ISV solution is used by our customers, they look at a whole lot of comprehensiveness in terms of offering, should be multi-cloud, etc. Right? So we look at that how we help lakehouses, AI lakehouses are designed to work well with this kind of integration with third-party tools, like I mentioned, which gives flexibility for our ISV partners to choose whether it is on the AI machine learning model side or whether it is on the generative AI model side. We have something called Model Garden, which help partners choose not only Google but open source model or bring in their own model and work on that. Yeah, so these are a few things which is how we are helping. And other than that, I think Arshad already covered about GTM and some of the programs we have, which we work together with IFC partners to help accelerate the adoption, etc.
All right. And also, as a follow-up question, if you could also tell me about the role of AI lakehouses when it comes to handling large and diverse data sets. How do you solve that problem? You're handling large and diverse data sets, but at the same time, you're trying to deliver real-time analytics.
Yeah, so typically we've seen, like Kunal initially covered this point, that when we look at typical data warehouse, right, the more data, more processing we do, it used to cost more, right? And then the traditional lake houses came in, which were good for unstructured data, for small file types and jobs which are more tuned for let's say data science kind of workloads, right?
Right.
The combination of both is basically is what AI Lakehouse is, and using the unified data structure and the architecture it gives on keeping the data, eliminating data silos in a very cost effective manner. And the second part is that we are looking at that how it is supporting on the performance side, right? So we looked at various engine options we have for different workloads, which basically again help move process and more workload, give the choice uh, of the language or the engine users have, and also deliver at a faster pace. Uh, so this I think these are two things. The third thing is, which is where people are today interacting with the platform, which Priyanka showed, right? And I think tomorrow, uh, in near future, we are seeing that most of the data products will be very conversational, and the conversational analytics is what we are seeing is going ahead. So we'll not have kind of dashboards and reports created every time. There will not be any backend team creating views and uh, dimensions and views for a particular report, but all this will be running through an interface which is very agile, through a natural language query, and
Mhm.
people can ask questions and get answers to take decisions. I think these are a few things I wanted to cover.
And I just wanted
Great.
to add something that the innovation that we are providing as part of our AI house, the speed is very high. If you look at
Mhm.
our race notes, like, for our BigQuery product, right, you see so many things, like, which are being launched in preview, which are going GA, general availability. So the pace, the speed at which we are launching the
Mhm.
features for the ISVs, I think that also is quite helpful and commendable, because you get to basically experiment it very fast rather than just waiting for a very long time, right? So you might want to build your own models, but if you want to experiment your idea, if you want to go launch the idea,
Mhm.
it saves you so much of time.
Correct. And a great point there, Priyanka. I mean, considering the hyper competitive environment that these companies are having to operate in. All right, now the last question, and that's going to be specifically for ISV's program. And Harshad, if you could take a stab at this, please. Tell us a little bit about what's new in your ISV program, and also, when it comes to ISVs, there are sometimes concerns around the possibility of vendor lock-in, or maybe competition ISVs may face with Google's own products. If you could throw some light on these two topics, please.
I'll take the second part first, Shomik. It's a very I hear quite a bit from founders saying that we are building products, right? Will Google compete with us?
Yeah.
And if we look at the Indian ISV ecosystem, it's a bit unique. Indian ISVs or SaaS players, if you see, are all solution providers, right? We have a ISV that is providing platform for logistics companies. We have an
Mhm.
ISV that is providing martech solutions. We have an ISV that is uh, helping e-commerce companies discover products better, right? So these are all solutions that are built on technology and have a certain amount of domain flavor. A Google Cloud Platform is a platform company, so we actually are giving platforms based on which ISVs are creating these products, which have a domain use case or a solution flavor to it, right? So in that case, it's more of a partnership rather than competition, right? So just to give an example, right? So if we have a martech platform, uh, they understand the market space very well, they understand that domain very well, they understand the customer journeys very well, right? But they would be partnering with us on AI and data, with folks like Kunal, Avinash, and Priyanka, to create that overall solution, right? So we are partnering with such ISVs rather than competing with them. And that takes me to answer the first part of your question, right? So, the kind of program that we have is a combination of three aspects, like I had mentioned earlier. First is the program has makes experts from our various technologies accessible to ISVs and SaaS providers. Experts like Kunal, Priyanka, Avinash, folks from our AI team that really build the innovation pillar for those ISVs, right? So that's the first pillar. Second
Mhm.
pillar is around GTM. Uh, we are building a very vibrant Google Cloud marketplace where ISVs and SaaS players list. The unique thing is there is a mechanism for Google to incentivize our sales team to sell partner solutions right? So that the marketplace model works beautifully. And the third is like the program that I mentioned around data and analytics migrations. We have programs that can take care of the cost economics and ensure that when SaaS players are selling the products in the market, the cost gross margins are taken care of, right? And cloud doesn't become a dominant part of the cost. So these are the three essential pillars that I and my team are driving. And like I showed earlier, quite a few Indian ISVs are working with us on this journey.
All right, great to know that. Avinash, would you want to chip in with a couple of sentences as well?
No, I think Harshit covered it pretty well. So I don't have anything else to add. Yeah, he's covered it pretty well.
All right, folks. Well, I think that's pretty much the time that we have for today's webinar. And thank you so much for joining us, Priyanka, Kunal, Avinash, and Harshad. I think it was a great all-round discussion, and I hope the audience learned as much from this particular webinar as I did as well. And thanks, audience, for tuning in. We'll be back with more, and have a great day ahead.
Thanks, Amit.
Thank you, everyone.
Bye-bye.